AI/ML case study success story, mentorship program. The video illustrates a conceptual representation of the random forest algorithm combined with k-fold cross-validation. Here's a detailed explanation of the key components. Pradeep K. Suri. Author, researcher, and AI/ML architect. 1 Title, Random Forest with K-fold. Random forest is an ensemble learning technique that combines multiple decision trees to improve classification or regression performance. K-fold cross-validation is a resampling technique used to evaluate machine learning models by splitting the dataset into k-subsets, folds. Each fold is used as a testing set once, while the others are used as training sets. 2 components in the video. A. Input arrows, on the left. The arrows pointing towards the trees indicate the input data. This input is a dataset that is divided into folds for cross-validation. Each fold is processed in turn. B. Forest of trees. The group of tree-like shapes in the middle represents the random forest. Random forest works by 1. Building multiple decision trees on randomly selected subsets of data and features. 2. Aggregating the results of these trees, example majority voting for classification or averaging for regression. See output arrows, on the right. The arrows pointing outward from the forest represent the output from the random forest model for each fold. This could be predictions for the test set in the cross-validation process. K-fold process. While not explicitly shown, the idea is that the dataset is divided into k parts, folds, and the random forest is trained and tested iteratively on different splits of the data. 3. Signature and date. The video is created by Pradeep K. Suri. The date at the top, December 10, 2024, marks when the video was documented. 4. Key process flow. Step 1, the input dataset is split into k subsets. Step 2, for each fold, a subset is used as the test set. The remaining data is used as the training set. A random forest model is trained on the training data. Predictions are made on the test data. Step 3, the process repeats for all folds, ensuring each data point is used for both training and testing once. Step 4, the results across all folds are averaged to evaluate the model's performance. Advantages of this approach. 1. Random forest. Handles overfitting well due to the ensemble nature. Works well with both classification and regression tasks. Can handle large datasets and high-dimensional spaces. 2. K-fold cross-validation. Provides a reliable estimate of model performance. Reduces bias by ensuring all data points are used for testing. Based on the video provided, which focuses on random forest and k-fold cross-validation, various AI models can be developed. Here's an overview of potential AI applications and models that leverage random forest and k-fold cross-validation for robust and accurate predictions. 1. Classification models. Application areas. Spam email detection. Disease diagnosis, example cancer prediction based on medical records. Fraud detection, example credit card transaction analysis. Image classification. Why random forest? Handles imbalanced datasets well. Can process high-dimensional data with many features. Model development. Train the random forest classifier using labeled datasets. Use k-fold cross-validation to ensure the model generalizes well to unseen data. 2. Regression models. Application areas. Real estate price prediction. Stock price forecasting. Customer lifetime value estimation. Why random forest? Robust to outliers in regression tasks. Can capture nonlinear relationships between input features and the target. Model development. Train the random forest regressor using numerical data. Use k-fold cross-validation to evaluate the model's prediction accuracy across multiple splits. 3. Time series analysis. Application areas. Energy consumption forecasting. Weather prediction. Sales forecasting. Why random forest? Can be adapted for time series forecasting by engineering lag features. Handle seasonality and trends through ensemble predictions. Model development. Use sliding window validation combined with k-fold to validate time-dependent data sets. 4 feature selection and importance analysis. Application areas. Identifying key factors in customer churn. Selecting relevant biomarkers for disease prediction. Why random forest? Provides feature importance metrics to understand which features contribute the most to predictions. Model development. Train a random forest model and analyze feature importance scores. Use these insights for dimensionality reduction or targeted interventions. 5 ensemble models. Application areas. Boosted trees for enhanced accuracy. Hybrid models, example combining random forest with neural networks. Why random forest? Works well in ensemble techniques by combining predictions with other models. Model development. Combine random forest with other AI models, example gradient boosting or SVM, for more robust predictions. 6 recommendation systems. Application areas. E-commerce product recommendations. Personalized content delivery, example Netflix recommendations. Why random forest? Handles sparse and categorical data efficiently. Model development. Train the model on user-item interaction data. Use K-fold cross-validation to validate recommendations. 7 decision support systems. Application areas. Loan approval systems. Risk assessment in finance. Medical treatment planning. Why random forest? Provides interpretable results and probabilistic outputs. Model development. Build decision support systems integrating random forest models for reliable risk assessments. 8 industrial applications. Application areas. Predictive maintenance. Quality control in manufacturing. Why random forest? Handles large-scale industrial data efficiently. Model development. Train on sensor data or production logs. Use K-fold cross-validation to ensure the model performs well on different subsets. 9 natural language processing, NLP. Application areas. Sentiment analysis. Text classification, example news categorization. Why random forest? Handles bag of words or TF-IDF features efficiently. Model development. Extract features from text using vectorization methods. Train and validate using random forest and K-fold. 10 custom AI pipelines. Integrated applications. Automated ML pipelines. Combining random forest with deep learning for tasks like image classification with feature extraction. Model development. Build pipelines where random forest handles structured/tabular data, while deep learning handles unstructured data. The video-visual representation of various applications of random forest AI models grouped into different categories based on their use cases. Each category lists specific tasks or problems that random forest can address effectively. The heading emphasizes that this work is authored by Pradeep K. Suri, indicating that he is the architect of this conceptual framework. Here's a breakdown of the key components of the video. Categories and their applications. 1. Classification models, red block. Applications. Spam email detection. Disease diagnosis. Fraud detection. Image classification. These tasks involve assigning data points to specific categories or labels. Random forest excels in handling large datasets and multiple features for classification tasks. 2. Regression models, orange block. Applications. Real estate price prediction. Stock price forecasting. Customer lifetime value. Energy consumption forecasting. Regression models predict continuous numeric outcomes. These applications leverage random forest's ability to estimate trends and relationships in complex data sets. 3. Time series analysis, yellow block. Applications. Weather prediction. Sales forecasting. Customer churn factors. Time series tasks involve analyzing data that changes over time, where random forest can model temporal patterns and dependencies. 4. Feature selection, green block. This focuses on identifying the most relevant variables from a dataset to improve model performance and reduce computational complexity. 5. Ensemble models, blue block. combines predictions from multiple random forest models or integrates with other algorithms like gradient boosting to enhance accuracy and robustness. 6 recommendation systems, purple block. Applications. E-commerce recommendations. Personalized content. Random forest is used here to analyze user preferences and behaviors to generate tailored suggestions. 7 decision support systems, cyan block. Applications. Loan approval. Risk assessment. Medical planning. These involve making critical decisions based on probabilistic and predictive insights provided by the model. 8 industrial applications, pink block. Applications. Predictive maintenance. Applied in industries to predict equipment failures and optimize maintenance schedules. Visual features. Colors. Each category is color-coded, helping differentiate between various domains and their corresponding applications. Horizontal bars. Each bar represents a specific application and stretches horizontally, possibly denoting the scale or importance of the use case. Background. The black background provides high contrast, making the text and colors visually striking. Overall, purpose. The video provides a clear summary of the versatility of random forest models in solving real-world problems across diverse domains. It emphasizes the breadth of their applicability, from healthcare and finance to industrial operations and e-commerce. Example. One-time series analysis, yellow block. Applications. Weather prediction. The line chart titled Weather Prediction for 2025, India, provides a visual representation of the predicted temperature variations in India for the year 2025. Here's a detailed breakdown of the chart. Components of the line chart. Axes. 1 X-axis. Labels, months of the year, March, May, July, September, and November 2025. Description. The X-axis represents the progression of time across the specified months. 2 Y-axis. Labels, temperature in degrees Celsius, degree C, ranging from 20 degrees Celsius to 45 degrees Celsius. Description. The Y-axis represents the temperature values. Data points. March 2025. Temperature, the line starts at approximately 20 degrees Celsius. May 2025. Temperature, the temperature peaks at around 45 degrees Celsius. July 2025. Temperature, the temperature drops significantly back to about 20 degrees Celsius. September 2025. Temperature, there is another peak at around 45 degrees Celsius. November 2025. Temperature, the temperature decreases to around 35 degrees Celsius. Trends and insights. 1 Seasonal variation. The chart shows significant seasonal temperature variations in India. Summer peak, the highest temperatures are observed in May and September, peaking at approximately 45 degrees Celsius, indicating the hot summer months. Cooler periods, the temperatures drop in March, July, and November, suggesting the onset of cooler weather in these months. 2 Temperature fluctuations. The chart highlights the considerable fluctuations in temperature within the year, with temperatures swinging between 20 degrees Celsius and 45 degrees Celsius. Transition months, March and November show transitional weather, with moderate temperatures compared to the peaks in summer. 3 Predictive analysis. This prediction can help in planning for weather-related activities and preparedness, such as agriculture planning, energy management, and public health measures to cope with extreme temperatures. Visual representation. Yellow line. The yellow line on the chart represents the temperature trend over the specified months. Peaks and troughs, clearly marked peaks in May and September, and troughs in March, July, and November, making it easy to understand the expected temperature changes. Summary. This line chart effectively illustrates the predicted temperature trends for India in 2025, showing significant seasonal variations with peaks in the hot summer months and cooler periods in March, July, and November. It provides valuable insights for weather-related planning and preparedness. Thank you.